In this video, I want to talk about zoom or digital zoom. If you look up page 163 in the book, we have an image like this, and we want to zoom in on it and make a bigger image, say a 4x4 image instead of a 2x2. So we can do it in several ways. We could do it by placing the 3-6 from here on the corners again, and then filling in the additional pixels that we want in order to make it a 4x4 image. And we can fill in by just replicating or copying the original pixels like this, copy the 3 and copy the 6. And this would be called zero order interpolation or nearest neighbor interpolation. But really it's no interpolation at all. It's just replication. We can do something a little bit more complicated. We could have the 3-6, the corner pixels again, and then we could fill in pixels here, which we get by interpolation. Let's say linear interpolation. So if we want 2 pixels there and these pixels are 3 and 6, then by linear interpolation, this will be 4 and this will be 5. Same here. So I want you to look at this worked example here where we've got 4 pixel values. This is in 1 dimension, 4 pixel values, 100, 150, 75, 125, and we want to zoom in and produce 8 values. Now the first pixel and the last pixel will be the same, and there'll be 6 pixels in between them instead of just 2 pixels in between them. So if we go to the next page, the original pixels are there, and we know their values from last page, but that's their position on a scaled picture, and we want to make 8 pixels out of them, where the first one is the same and the last one is the same, but we want to construct 6 pixels in between. Pixel 2 is going to be a combination of the original pixel there and there, and it's going to depend on the relative distances, that distance and that distance. Same with pixel 3 is a combination of the original pixel 1 and the original pixel 2. It's going to be more like the original pixel 2 and less like the original pixel 1 because it's further away from it. And so on, you work through 4, 5, 6, and 7. But work through this here and see whether you can understand it. There's a homework question like that coming up. That's interpolation in 1 dimension. In 2 dimensions, we can have the original values and then build in additional values. If we look at this simpler picture of this, we've got original values here, and we want to zoom in on this 2x2 picture to make a 5x5 picture. And we're going to ask, what are these additional pixels that we need? What are the values of them? Well, the values of them depend. In this case, the value here would depend on that and the distance from it, and that value 40 and the distance, and that value that, and that value that. And it would be a linear interpolation of those 4 values depending on the distance. Now, 2-dimensional distance is something we need to think about. 2-dimensional distance is not that distance there. It's not the sum of the squares. It's not analog distance. It's not Pythagoras. That's what we use for analog distances, but we're using digital distances. So the distance of that, from that to that, is either 1, 2, 3, or on another system, it's 1, 2. And you need to think a little bit about those different distances, those different digital distances. But instead of doing two-dimensional interpolation, where we have to start off and be clear which distance we mean. Do we mean a distance of 3 in that instance or a distance of 2? They're two different systems. But instead of doing that two-dimensional, we could do it by one-dimensional linear interpolation and then do it in the horizontal direction and then repeat it in the vertical direction. So for instance, if we interpolate horizontally, this is going to be 30, this is going to be 25, this is going to be 35. So this value is 30, and from the same argument, this value is 70 when we do one-dimensional interpolation in that direction. And then we'll do one-dimensional interpolation in this direction. And this was 30, this was 70. So this will be 40, 50, 60, 70 by linear interpolation, and the value of this will be 40. So that's the way most software does it, as two linear interpolations, two one-dimensional linear interpolations, rather than trying to work out two-dimensional distances.